Hi everyone, hope you're having a great day today. I just uploaded the exam 2 review in Blackboard in the content folder, so go ahead and review that. Now just be aware that it's not completely going to have every single questions in there, but it will give you samples and an idea of what to expect. Okay, so last time we left off at 10.3. Now we're going to continue 10.4, which is the inverse functions. So let's review a little bit of algebra. I think we learned inverse function in algebra, and we're going to look at some of those properties today before we apply in for trig functions. So in order for a function to have an inverse, it must be 1-to-1. What does that mean, 1-to-1? So 1-to-1 means that for each x value, it only corresponds to one y value. So basically, the y values are unique.
Hey, Professor, can you share the whiteboard link again, please?
Oh, yes.
Thank you.
Okay. Okay, so in order to test to see if a graph have an inverse, we can check to see if it passes the horizontal line test. So let's remember that if a graph is a function, then it passes the vertical line test. Okay, so if a function is 1-to-1, then it must pass the horizontal line test. Okay, or HLT for short, and VLT. Now remember that 1-to-1 is a property of a function, so therefore you have to test the vertical line test first before you pass the horizontal line test. Okay, so the notation for inverse is f of to the -1. Now remember that f of -1, just be careful here, f of -1 of x is not the same thing as f of x to the -1. Do we know why that is? Anyone? Well, on the left-hand side, this is the inverse notation. On the right-hand side, this is the reciprocal notation, which means that it is equal to 1 over f of x. Okay, so be careful with that. All right, so whenever you are looking at the inverse, the domain and range will switch. So basically the domain will become the range of the inverse, and the range will become the domain of the inverse function. And graphically, the graph will reflect across the line y equals x. So if we were to draw a function here, so there we make sure that it is a 1-to-1 function. So we can see that it passes the vertical line test. If I were to draw a vertical line, it only touches it one time. If I draw a horizontal line, you can see that it only touches it one time. So therefore, this is a 1-to-1 function. Okay, so in order to see what is the inverse of this, we call this one f of x. All we have to do is reflect it across this line, y equals x. Okay, so if we reflect it, we'll get something that looks like a mirror of this image, something like this. Okay, So basically it's just a reflection over. Now, let's apply this to trig functions. First question is, are trig functions one-to-one? Mai, what do you think? Mai? No? Nicholas?
Repeat the question. I didn't get to hear it. I was
It's written on the board. Are you following the whiteboard or are you following Blackboard?
I'm on Blackboard. It just took a second to update. I got it now.
Oh, okay.
I'm pretty sure that trig functions are one-to-one.
Okay. Why are you so sure?
For every x that you input, for every input, there's one output.
Okay, well, let me sketch an example for you. So let's say I have sine functions. It goes on forever, right? So by just looking at that, does that pass the horizontal line test?
Yeah, never mind on that one. It doesn't.
Okay. What about cosine? Does cosine pass the horizontal line test?
Nope.
Okay. What about tangent? Oops, that's not tangent. That's tangent. And that, keep going like that. So that doesn't
If
work
you
either.
keep going,
Go ahead.
I said if you keep going, then no. If it's in that set interval, it would, but if it keeps
Exactly.
going from negative, yeah, exactly.
So that's the idea, right? So here's cosecant or secant. So the idea here is, okay, if you were to restrict the graph of any trig functions, you will be able to make it one-to-one. So that's the idea that we want to look at, okay? So how do we find one-to-one? Well, in order to find one-to-one, all you have to do is switch x and y and then solve for y. So let's do a real quick, easy example here. Y equals to 3x minus 7. So this is just a linear function, which is really easy to find the inverse of. So we're going to switch the x and the y, and then solve for y. Divided by 3 on both sides. So there it is. This is our inverse of 3x minus 7. So that's nothing to it, right? All right. So let's look at our trig functions in details. So here, we can see that it definitely will not pass the horizontal line test unless we restrict it to some interval, not open interval, just to some interval. So here we choose from negative pi over 2 to pi over 2. And you can see here that this distance or this interval, okay, so the graph will look something like this. Now it is one-to-one, right? So if we restrict the domain from negative pi over 2 to pi over 2, therefore it will become one-to-one. Now remember that this is sine and it is restricted to quadrant 4 and quadrant 1. The reason why that is because we need to have one quadrant that is positive, one quad to be positive, and one quadrant to be negative. Okay, so remember our ASTC? The reason why we didn't get the second one is because it is not negative, right? We need one positive, one negative, and so the first quadrant is always positive. Now we don't use the third one because it will not be continuous from 1 to 3. So we just can't pick like this region and this region because it is not one continuous graph. So note, okay, no trig functions, no inverse trig function will exist in quadrant 3 ever. Okay, so it's either 1 and 2 or 1 and 4. Okay, so you're going to see which function is 1 and 2 and which function is 1 to 4. And it's really easy to remember because all you have to remember is in quadrant 2 and quadrant 4, which one is it negative. Okay, all right. All right, so here you're going to have to memorize this. The inverse sine function, okay, we use arcsine or sine inverse, like -1. I normally use this. I don't really use arcsine because that's just too much stuff to write. So sine inverse here is much quicker. Now, remember that the values that we restricted in was -pi/2 to pi/2. So when you're trying to find the arcsine of it, the x and y switches. So you can see here now the y has this restriction of -pi/2 to pi/2. Okay. All right, so let's look at cosine and see where we need to restrict it to make it 1 to 1. All right, so let's talk about cosine. Cosine look like this. All righty. So what quadrant do you think I need to restrict it to make it 1 to 1? Anybody? Nicholas, what do you think? Mine? Aim? Nobody?
Is it 1 and 2?
1 and 2, right? Because in quadrant 2, which is right here, we see that it is negative. Right, so I told you that it's always going to be 1, and then we need another quadrant so that's negative. So in quadrant 2 it's going to be negative. So quadrant 1 and 2. Okay, or you can remember it as from 0 to pi. So this is our restricted interval. All right, so for tangent, looks like this. And then keep repeating again. All right, so we can see here we have a continuous from -pi/2 to pi/2. However, we cannot use these endpoints because we have a vertical asymptote there. So the restricted would be -pi/2 to +pi/2 without the endpoint. All right, so for secant, its reciprocal is cosine. So we're going to have vertical asymptotes here and here. So that means that we have a, all right. So now what do we need in order for it to be 1 to 1? What do you think? Can I choose 1 and 4? Well, if you choose 1 and 4, it is not 1 to 1 because you can see here that does not pass the horizontal line test. So we have to choose this piece right here and this piece right here, which is in quadrant 1 and 2. So, however, we do have a vertical asymptote here at pi/2, so we have to restrict it from, so the domain that we need to restrict it to is from 0 to pi/2, and then union pi/2 to pi. Okay, cosecant, very similarly. So cosecant, we have reciprocal of sine, so it looks like this. Vertical asymptotes here. And we have to choose this piece and this piece. So it'd be from -pi/2 to 0. and then 0 to pi over 2. Okay, so this is the domain that we need to restrict it to. And the range for it will be from -infinity to -1, union from 1 to positive infinity. So this is our original function secant, cosecant, right? If we take cosecant inverse of x, that means that the domain and range here will just switch. So that means the domain of my cosecant inverse is -infinity to -1. And our range will be the domain of cosecant function that we restricted it to. Pi over 2. Okay. And then it's very similarly for these other ones here.
Hey, Professor, can we go back to that cosecant graph that you drew out?
Sure.
So I know that you the range of the cosecant function. Can you highlight in a different color on the graph the range of the inverse cosecant function? It's going to be the opposite side of that secant parabola, right?
It's this right here. Range of the cosecant inverse.
Sure, and then on the
you want me to sketch the function?
no, sir. Just like okay, so that's the green part. I see what you mean now.
Yeah.
Okay, thank you.
So that's a cosecant function. Okay, we're not drawing the cosecant inverse.
Oh, okay.
Yeah, so this is the cosecant function that we restrict it to, and then after this, I'll show you the graph of the inverse function. This is all the graph of the parent function, the original one.
Okay, thank you for the clarification. That helps a lot.
Yeah. All right, so that we'll look at the in a second. We just talked about the domain of it here. Okay, so let's get into how do we find out the value of the inverse. And again, we're going to go back to that unit circle with the first quadrant. So you have to really remember that unit circle, okay? All right, so here, let's look at how we do this. Y equals to sine inverse of 1/2. This here is saying the same thing as sine of what is equals to 1/2. Right? So now, what angle does sine of that angle equals to 1/2? Anybody remember this? Sine goes here, cosine goes here. 0, 1, 2, 3, 4. Square root over 2, square root of 2, square root of 2, square root over 2. So it is this one right here, which is 30 degrees. So y is equals to 30 degrees or pi over 6. Is that okay? Nobody?
Yes.
Okay. So part B, sine of y is equals to 1, which is the same thing as saying y is equals to sine inverse of, oh, that's -1, of -1. So where is sine -1?
3 pi over 2.
Thank you. So 3 pi over 2 is our angle, or 270 degrees. Okay. What about sine of y equals to 2? So now, go ahead.
I was just going to say that's not an angle, or it's not existent, I guess.
Yeah, so that does not exist, right? Because you can never
Outside the
sine of something to get 2, because that's outside of our range, okay? Okay, very good. So it does not exist, so D and E. All right, so now let's look at the graph of the following. All right, here you can see, actually, maybe we can look at the graph of both of them so we can kind of see, okay? So I'm going to pull up my calculator and show you this. All right, there we go. So first, make sure I'm in the right mode. So that's radian, that's good. And so I'm going to type in just sine of x, and then I'm going to write sine inverse of x, so we can see the difference between the two. And let's restrict it from, let's see, negative pi over 2 to pi over 2. All right, and I'm going to do zoom square just so that I have a correct representation of it. Okay, so let's zoom in a little bit. All right, perfect. So now you can see here, if I were to show you the line y equals x, you will see, let's make this a dashed line. You will see that it is a reflection, okay? So you can see here, all right, the blue one is my original sine function. The black one here is y equals x, which is the line that it will reflect over. And the red one here is my, my inverse function. So you can see it's a reflection over it, okay? All right. So let's go back to our whiteboard. Okay, so you can kind of see here that the graph of sine inverse looks like this. Okay, and you can see that both x and y-intercept are 0, 0. So for the inverse and the original sine function. And the graph is symmetric with respect to the origin, so it is an odd function. So you can see that if I were to reflect this over the x and y axis, it will be an odd function, which is the same thing for sine. And similarly, we can see that the graph of inverse cosine, we restrict it to 0 and pi, which is the first and second quadrant. And that is because in second quadrant, cosine is 0. And if I take this and I reflect it over the line y equals x, I will get this function over here, which is the inverse. Now, it's the same thing here. If you want to look at how to find function value of the inverse function, just think of it as cosine of y is equals to 1. So when does that occur? That's when y is equals to 0. And then same thing here. Cosine of y is equals to square root of 2 over 2. So that means y have to be 45 degrees or pi over 4. Okay. Oh, this is negative, sorry. This is negative, so this has to be 135 or 3 pi over 4. So this is in the second quadrant because it's negative. Okay. All right, same thing for tangent. For tangent, we are going to restrict it from negative pi to pi over 2. And if we reflect that graph over the line y equals x, you can see here, our domain is actually our real number for the inverse tan function. So you can see here it goes all the way from negative infinity to positive infinity, but it is bounded in the range from negative pi over 2 to pi over 2, which is basically the bounded domain of our original tan function. So remember that the domain range just switch. Okay, and here is just properties of its inverse function. You can see that the domain negative infinity to positive infinity, both of them have 0, 0 as their x and y intercept, and it is symmetric with respect to the origin. And we have two horizontal asymptote, y equals pi over 2 and negative pi over 2. So this one right here is as x approaches positive infinity, and this is as x approaches negative infinity. And here I just explained that what I've been using. if you're taking y equals to any inverse function of x, that means that that function of y is equals to x. Okay. Be aware that sine, or actually it's right in normal, f of f inverse of x is the same thing as f inverse of f of x, and they all equal x. Okay. And this is true for any function, assuming that the inverse exists. And this is a summary of all what I've just said. So I'll give you a second here if you want to take a picture of that or jot it down. Okay, so just want to remind you again that notice that quadrant 1 is always in the restricted domain, and it's either 2 or 4, whichever function, whichever quadrant that function is negative. So all of these right here are negative. Okay, so the function would be negative in that quadrant. You can see here in the fourth quadrant, sine is negative. Okay, in the second quadrant, cosine is negative, and so forth. Oh, you may also wonder, why did we use the fourth quadrant instead of the second quadrant for tangent? Because it is negative for both second and fourth, right? So that's a curious question there. But if you look at the graph of tangent, the graph of tangent is continuous from negative pi over 2 to pi over 2. So that's why we want to keep it continuous instead of looking at this piece and this piece where we have this this vertical asymptote right here. Okay, so this is important here. If you want to find out the inverse of the following function, where there's no button on the calculator for it. Okay, so for tangent and cotangent, there is a button. For sine and cosine and its inverse, there is a button for that. But in order to do cotangent, secant, and cosecant with the calculator, it's not as straightforward and it's not that easy. Okay, so we kind of have to play with it. So let's look at some example. If y is equal to secant inverse of x, then secant y equals x. So that's true. That's always true. Then we have to write it as the following. Okay, so we have to basically rewrite it in terms of cosine. Okay, so we know that secant of y is equals to x. So then we're going to do 1 over cosine y is equals to x. So we just replace the secant with its reciprocal. Then we can solve cosine y is equals to 1 over x. So if we want to find secant inverse, then we have to find cosine of 1 over x. So you can see here, this is the reciprocal, okay, of what we're actually trying to find. But since we're trying to find the reciprocal function, that's why we have to do this extra step here. Okay? Does that make sense or no? So we have to use the reciprocal function in order to find its inverse, where we take the reciprocal of the argument. Well, let me phrase that for you. Okay, again, the argument is everything in this parentheses. All right, let's do these. You're gonna need your calculator. Or not. Well, you should be able to find these values here now. All right, so y is equals to cotangent inverse of negative 1. All right, go ahead and find that. Let me know what you get. Nicholas, what you get for 1? Or A?
3 pi over 4.
Why is that?
Because it'll be in quadrant 2 for cotangent. And
Mhm.
so the value is -1. So it's going to be a pi over 4 reference angle, I guess you could say.
Yeah, that's right.
So the values for that is the square root of 2 over 2 over square root, or negative square root of 2 over 2. So that's angle 3 pi over 4.
Very good. That's exactly right. All right, B. Mohammed? You here? Aim?
I'm here. I'm sorry. I'm still working it out.
Okay. So just flip it and then take the reciprocal function. So what is the reciprocal of secant?
It is cosine.
Cos-
All right. And then you're going to flip this, which is 1/2. So this is like saying cosine of y is equal to 1/2. So what is y?
It
Come
is
on.
60 degrees, or pi over 4.
Pi over 4 is not 60 degrees.
Pi over 3.
3. Yes. Okay. All right, good. All right, Mai? You hear Mai?
Yes.
Okay. What is C?
Let's see. I get sine
Okay.
three.
Okay, now what? You should probably rationalize this.
Oh, I'm 10 3 pi 3 over pi 3 is
So you get 3 square of 3 over
3 by
2
over
times 3.
2.
Hmm?
2 times. And cancel 3. Yeah.
All right. So sine of y is equal to square of 3 over 2. So what angle is y? What angle gives you square of 3 over 2 for sine? Zero,
Oh,
1, 3. What angle is this? You remember this? 30, 45, 60. So it's 63 or pi over 3. Okay, need to memorize that. All right. Let's continue this one over here. Tangent. All right, each one of you get one. So, Eric, are you here?
Oh, I just joined. I was having trouble with my computer.
Okay, but do you know what's going on, or you're catching up?
No, I don't know what's going on.
Okay. Okay, so here, well, if I ask you tangent of theta equals to 1, Eric, can you tell me what theta is equal to? I'll give you an easy one. How about this? Sine of 1/2. Oops. Sine of theta is equal to 1/2. Can you tell me what theta is equal to?
Yeah, it's 45 degree or
Nope.
like degree or radians?
You can use either one. I don't care, whatever you prefer. But it's not 45.
Oh, no, it's 30.
Yeah, it's 30. All right. What is theta when tangent inverse is 1? Should memorize this one. Aim, what about you? Or Mohammed?
I'm sorry, can you repeat that?
Part A, tan theta is equal to 1. What is theta?
Theta is equal to 45 degrees or root 2 over 2.
That's the value of it, but the angle of it is pi over 4.
Oh, okay. Okay, I see what you mean.
Yeah, root 2 over 2 is the value of sine cosine. All right, Nicholas, what about part C?
Pi over 3.
Pi over 3. Very good. Seems like you're the only one that memorized the unit circle. All right, let's continue. Let's see. Ooh, here we go. Let's go to some harder ones. All right, so now we need to find out sine of tangent inverse of 3 over 2. So this one is going to tickle your brain here. Tangent cosine inverse of -5 over 13. All right. So let's summarize what we just learned here. An inverse function will always give you a what? Nicholas? Always return an angle, okay? So tan inverse of 3/2, this is an angle, theta. Now, do I have to know what that theta is? No, not necessary. Okay, so that means that if I want to find out sine of that angle, then I have to sketch out my triangle. So here, it requires you to know a lot of things. Everything that we've learned up to this point You have to put it together in order to do this problem, which is why it's a little bit more involved. So first thing first, you have to know what quadrant this tan inverse exists in. We know it's 1, but what is the other one? What other quadrant? 4. It's positive, we're going to sketch it in the first quadrant. So tangent is opposite over adjacent. So opposite here is 3, adjacent here is 2, right? So that means my hypotenuse is going to be 9 plus 4, which is square root of 13. Now that I have my right triangle set up in the correct quadrant, now I can apply sine of that theta. You can see here, I don't care what theta is because I'm trying to find out what is the sine of that theta is. So sine is opposite over hypotenuse. So that means I can take 3 divided by square root of 13 and rationalize it. So my final answer is 3 square root of 13 over 13. Okay, any questions? All right, I'll give you some time to try B. Right, raise your hand when you're done and write the answer in the chat. Mai, were you able to do it?
Yes.
Okay, so you see here, this is cosine, and the value is negative. So cosine is going to be negative in the second quadrant. Okay, and cosine is adjacent over hypotenuse. So adjacent here is going to be negative 5. Hypotenuse is 13. Now remember that hypotenuse can never ever be negative. So that's why that this here is negative. And it makes sense because this is my x value and it is negative. So now I can use the Pythagorean theorem in order to find out what is my y value is. And this is a special triangle, 5, 12, 13. But you could also take 13 square minus 5 square. Okay. All right, so now that we have that, we need to find out what tangent of theta is equal to. Tangent is opposite over adjacent. So opposite is 12, adjacent is -5. And so there's my values. And it looks like you guys got it. Oops, let's see. All right, let's do these two. Sine of tangent inverse of 3/2, and B, tangent cosine inverse of -5 over. Wait, do we just do that one? Or wait, did we just do that one? So 3/2.
Yeah, these look familiar. I think we've done these.
Yeah, it's the same thing. Oh my god. Okay. All right, let's do this one. Cosine of tangent inverse of square root of 3 plus sine inverse of 1/3. Oh man, look at that. That looks complicated. What to do? You guys want to discuss how you approach this problem? What do you think, Nicholas?
Do you go from tangent first or sine? That's where I'm lost. I don't know which one you would start with.
Okay, that's a valid question. Anyone else want to chime in and see if you can help?
I think the order of operation states we have to do whatever is in parentheses first. So we would have to do the sine first because it's encapsulated in the parentheses of the tan inverse function, right?
Okay, sure. But also, I mean, inside it's addition. So addition is commutative. Like 3 plus 4, same thing as 4 plus 3. So it doesn't matter which one you evaluate first.
Okay.
Okay. So, yeah, discuss. What would you do? Do it together. Write on the board. Maybe one of you take 10 and the other one takes 9 and see if you can come up with something. Go for it. Talk to each other.
All right. I will take tan. And then we know that inverse of tan is going to be in either quadrants 1 or pi minus 2. So 4, right? We see that rad 3 is positive. So then we know this is going to be sketched in quadrant 1.
Okay, go do it. Inverse.
That's what I'm working on now. I'm just doing it on paper first, and then I'll write on the board.
Sounds good.
Okay. And we know that tangent is going to be Professor, this is where my logic gets shaky. I know that tangent is opposite over adjacent, but is there a way that I can confirm that the adjacent is 1?
Well, that's number, like a rational number. You can change any number to a fraction by just dividing it by 1, right?
Yeah. Okay.
So yeah.
I'm going to try to write theta. Okay. Theta 1, 3. makes it a, let's see. So,
Okay, make any more progress over there, Nick?
I'm kind of stuck from here. If you could explain, that would be great.
Okay. All right, so let's step back a little bit and look at the original problem. Okay. The original problem was cosine of tan inverse square root of 3 plus sine inverse of 1/3. Now, I told you earlier that anytime you see an inverse function, that's going to be an angle. I'm going to call this one A and this one B. And A and B are going to be my angle. Okay. So for tangent, this one would be A and this one would be B. Now, this is the sum of cosine. Okay. So what is the formula for the sum of cosine? Anybody?
cosine A cosine B minus sine A sine B.
Right. That means I need to find out what is cosine A cosine B, sine A sine B. Well, I'm going to use this and this in order to find that. So cosine A give me what? What is A? It's right over here. Cosine A is
1/2.
adjacent over hypotenuse, so that's 1/2. Cosine B over here, adjacent, so this is square root of 8, right? Over hypotenuse, so square root of 8 over 3.
Okay, I see where you're going with that. That makes sense.
Yes. So sine 2, sine B 1/3. Now we simplify. By the way, square root of 8 is equal to 2 square root of 2. So we can simplify that. 2 square root of 2 over 4 minus square root of 3 over 6. So we can simplify that by 2. Square root of 2 over 2 minus square root of 3 over 6. That would be our final answer. Well, if you want to combine those two, so 3 square root of 2 minus square root of 3 over 6. All right? Okay. So that took like 4 slides to finish. Right? Okay. Wait, they got 2 square root of 2? Did I mess up somewhere? Did I mess up right here? That's 1/2, right? Yeah. Oh, this is 3 right here. Sorry. So we can't cancel that. So 2 over square root of 6. So yeah, so 2 square root of 2 over 6. That's the 2 here. Okay. All right, next, let's try this one. Tangent to sine inverse of 2/5. All right, so now what identity is this? Again, here's the hint. Anytime that you see an inverse function, you think an angle. So let's say all that is theta. So go from there. You're going to sketch out what theta is using sine inverse of 2/5. Okay? Go from there. Eric, what is the formula for tangent of 2 theta?
Well, tan, I know, is opposite over adjacent.
Yeah, but this is the double angle formula.
I'm not sure.
Okay. Mohammed, what about you? Eric, did you attend last lesson?
Not yet.
Okay, that's probably why. So you go back and watch that.
Yes.
All right, AIM, what is the formula for tan 2 theta?
The formula for tan 2 theta is 2 tan theta over 1 minus tan squared theta.
Very good. All right, so now we need to find out what is tan theta is, and we can do that using this to determine what is theta. So sine inverse here is positive, so that means it's going to be in the first quadrant, right? So we have sine, which is opposite over hypotenuse. So it's 25 minus 4, so that's square root of 21. All right, so now we can find out what tangent is, which is opposite over adjacent. So tan theta is opposite over adjacent. So now let's put it in here. So 2 times 2 over square root of 21 over 1 minus 2 over square root of 21 square. So this is why I didn't rationalize it first, because here you can get rid of that anyway. So up top, you have 4 over square root of 21. On the bottom here, we have 1 minus 4 over 21. So we can combine the denominator by finding common denominator. So by multiplying top and bottom by 21, so we get 21 over 21. So 4 over square root of 21 divided by 17 over 21. To divide fraction, we multiply by the reciprocal. And here we go. So whatever that is, 84 over 17 square root of 21. And we can rationalize that by multiplying by square root of 21. Now you can keep going and simplify that. All right. Oh, there you go. So you end up with 4 times square root of 21 over 17. All right, here are the next two. Sine tangent inverse of u. So now this time you don't get to know what is the angle is, or even the sides. Everything have to be in terms of u now. So how do we do that? Well, we do it just exactly as we've been doing before. Okay, so tangent inverse of u. So we can make this a fraction by putting over 1. Now you have to assume here that it's going to be positive. Okay, that's one of that assumption. So tangent inverse, okay, so opposite over adjacent. So that means this hypotenuse is u squared plus 1 square root. And this is theta. So this whole thing here, we can call that theta. So sine of theta is equal to opposite over hypotenuse. And that would be your value. You're going to have to know this in calculus 1 very well when we do trig substitution. All right, I'll give you
Professor,
some
for this
time.
one, do we rationalize the denominator for this one as well too?
No, you don't need to.
Okay.
All right, I'll give you time to do B. Okay, are we done yet?
I think I got an answer. I'm just not sure if I'm doing it right.
Okay, what'd you get?
I got 2 times the square root of 1 minus u squared.
2 times the square root of what?
1 minus u squared.
Okay, that's it?
That's all I can get to.
Okay, Nick, did you get the same thing?
I'm still working on it. I haven't gotten any.
Okay, what about you, Mai?
I'm still working.
Tell me what you did so far, Mai. What do you have so far?
I'm drawing the triangle like you drawing.
Okay.
Yeah, and I write again the question.
Okay.
And the cos 2, I remember, is equal. Yeah, it's equal 1 minus 2 sine square.
That's right.
Yeah.
Yeah. So we can find out what sine is equal to, right? So we have a formula for it. We have a triangle for it. So we basically can find out what it equals to, right? All right, so now we can find out what is sine theta is equal to. Well, sine theta is just u over 1, which is u. So here we got 1 minus 2u squared. That's it. The end. Any question? Are we okay?
Yeah, I see where I went wrong. I get it.
Okay. Okay, let's see what else we got. All right, I think this is the last problem. Okay, cool. All right, the optimal angle of elevation, theta, a shot putter should aim for to throw the greatest distance depends on the velocity of the throw and the initial height of the shot. One model for theta that achieves this goal is arc sine of the square root of velocity square over 2 velocity square plus 64h, where h is the initial height and the velocity here is v, and that will give us our greatest distance d. Okay, so now we can find out what the question is here. Suppose a shot putter can consistently throw a steel ball with a height of 7.6 feet and the initial velocity to be 42 feet per second. At what angle should he throw the ball to maximize the distance? Okay, well, all we do here is plug it in. Theta is equals to arc sine inverse of the square root of v squared, well, 42 square over 2 times 42 square plus 64 times 7.6. Well, that's just plug and chug, right? So plug all that into your calculator. So this is nothing really interesting here. Now, you don't have to memorize this formula for the test because I won't ask you it. If I were to ask you this, I would give you this formula. So all the identities you should memorize, all the double angle, all of the Pythagorean theorem angles, yeah. And about 42 degrees. Okay. Wow, we finished early today because nobody asked questions. Oh, any questions?
Can we go over another example of using an inverse identity with other identities, like the last one we used, the double angle identity? Can we get more examples of that, please?
Yeah, let's look up this session and see if we can do it. So this is what 10 point something. 10.4. Lucky for you, we have a ton. All right, so basically anything from 85 to 90 should fit your need. So pick one, do it, and then let me know if you have problems, and then I'll go over it after you're done. So raise your hand when you're done. Yeah, go ahead and type in the number you want to do too. 90 looks good, so yeah, everybody do 90 then. All right, very nice. Okay. So let's see. Do you want me to work it out? Anybody else? Eric, you want me to work it out? Maya, you got it?
Yes, please.
Okay. All right. So if you can tell me the thing after I exit out of here, I'll say. So 3/5 and 5/13. Okay. Can you read me the problem again?
Sure, it's cosine of cosine inverse of 3/5
Hold
plus
on,
sine
hold on.
inverse
Chill. Cosine of cosine inverse of 3/5,
plus sine inverse of 5/13.
5/13. Okay. So this is cosine of A plus B, where this angle here is A and this angle here is B. So this means I can rewrite this as cosine A, cosine B minus sine A, sine B. All right, so here let's create the triangle. They're both positive, so that means that it's in the first quadrant. Cosine is adjacent over hypotenuse, and this is a 3, 4, 5 triangle. And for B, we have sine, so that's opposite over hypotenuse. So this is a special triangle, 5, 12, 13. So let's just plug it in. So cosine A, cosine is 3 over 5 times cosine B, 12 over 13, minus sine A, 4/5, times sine B, 5 over 13. Okay, now to multiply this together, we have 36 minus 20 over, let's see, 65. So we have 16 over 65. All good?
Yes.
All right. Any more?
Yeah, I'm always game for more.
Okay. All right, pick another one, or we can actually do an identity. So, oh yeah, here's more. You can pick that if you want. Ooh, look at that square root.
What's the range of questions we can pick from? From what, 91 to 106, sir? Or is it 91 through 96?
You can pick anything except 97 to 100,
Okay.
because that's just plug into the calculator. So. All right, are we all done? So to check this, if you want, you just type in the calculator, by the way. See if you guys get it right. Without working it all out. And I want you guys to do, let's do 112 when you're done.
Hey, Professor, quick question about the test next week.
Mm-hmm.
Will there be a graphing portion?
No.
Okay, thank you. Hey, Professor, another question.
Go ahead.
When you're using U in these formulas like 112, do we always assume that U is going to be in quadrant 1?
Yes.
Thank you.
What was that other question you wanted us to do? So 109?
112.
All right.
All right, got it. Huh? Okay, let's see. All right. So someone read 112 to me again.
Cosecant of arctangent square root of 9 minus u squared over u.
Okay. All right. So the hypotenuse here, the R value will be 9 minus u squared plus u squared. So that cancels, so that's just 9. All right, so cosecant of that, okay, cosecant is equals to 1 over sine. So let's just take the reciprocal of sine. Sine then is opposite over hypotenuse, so reciprocal of that is 9 over square root of 9 minus u squared.
Oh wow, I complicated it.
Eric, how'd you get your numerator? It looks super complicated.
I think I did the Pythagorean theorem here wrong. I just used the wrong variables for it, but I see your logic.
Yeah. Okay, good. Yeah, so this right here is being used in calculus a lot. So you have to be able to recognize how a trig comes into play, especially when you're dealing with something like this.
Do we have another application type question for this section?
Let's find out. There's a lot here. So we can do this right here, or the airplane problem, or this. Oh, this is good right here. Oh yeah, in calculus 2, we'll be doing something like this, basically trying to find out the volume of whatever that's left over after, let's say there's a spill or something like that, or a leak. You can find out how big the hole is by just how much is leaking. All right, let's try number 117. Actually, this is fairly easy. If you get it, let me know. Or if you need help, let me know. Okay, so this is what we have. So what we want to know is to show that if theta is the angle in the figure below, we want to find out the angle, right? So we know that this entire thing, right? Oops, can I draw on this? No. Wait,
So are you on the whiteboard right now? Oh, okay, there we go.
yeah. So if, why can't I draw? Okay, there we go. This is pi. So what we want to know is what is this angle right here and this angle right here. I'm just going to call this one theta 1, theta 2. So basically theta 1 plus theta 2 plus theta equals pi. You guys agree with that? Right?
Yes, I agree.
All right. So now we have to find out what is theta 1 and theta 2 is equal to. Okay. Well, we have this distance, that's 75, and we need this distance, which is 100 minus x. Well, that's just opposite over adjacent, right? So tangent of theta 1 is equals to opposite over adjacent. And then over here is the same thing. Tangent of theta 2 is equal to opposite, which is 150 over adjacent, which is just x. So we can solve for theta by taking arctangent of each one of them. So theta 2 is equals to tan inverse of 150 over x. Same thing over here. 75 over 100 minus x. So when we solve for theta, we just subtract these two, bring it over here, and we do a direct substitution for this one and this one. So that's how we got this formula. That makes sense? Should I clarify anything, or if you guys don't understand something, let me know.
Okay, I see how you did that.
Anything else? See if the homework is. Yeah, homework's fairly easy. I think we did all the examples that is in the homework. Yeah. All right, so I'm gonna call it a day here. Let me know if you have any questions or shoot me an email. And the review is already up by now.
Awesome. Thank you so much.
All right, have a great day. See you next week.
Bye.
Thank you.